And we have a tangent to the circle. Now, what is the tangent? Let's drop that one first. I said I will come and ask this in this class again. I know people will tell me stories. They will remember the wrong one in Akiola, but they will not remember the correct one. Hey, I am on camera. But I'm saying the truth. The truth is the truth. They will always remember the wrong one, which is in Akiola, but they will not remember the correct one that I teach. What is the tangent? They are referring to their notes before they tell me. That tells me that you didn't open the notes since the beginning last night. Yes, sir. You're waiting for me to come before you open it. God forgive your sins. Say amen. Yes, tangents. 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 Yes. See, when I'm asking tangent, he's lowering his height. Yes. So that I shouldn't see him. Yes, tangent, yes.
It's a straight line. Drawn from outside of the circle. And if extended, does not touch any part of the circle.
You were referring, you didn't finish referring.
So
go back and look at it again.
Understand it.
That's your understanding.
Yes.
The understanding is porous. I want a better approach. Yes? A tangent.
It's a straight line drawn from a point outside of the circle. To touch just a point.
We are defining it, we are not paraphrasing it. So if you are defining, please choose your words carefully. What is the tangent? You are defining the thing. You are not paraphrasing it. What is the tangent? What is the tangent? Yes. Tangent, yeah. Tangent is a line going from the outside of the circle, touch the circle 30 meters. When it is 7, don't cut together. Something's still missing there. Something is still missing. I'll give that 7/10. I want a 10/10 answer. Tangent, yes. You replenish at the end. It's a straight line drawn from outside of a circle or a curve. It's not always what a circle, it could be a curve. Drawn from outside of what? A circle or a curve. To touch it at a point such that when produced, it does not what? Come through it. Is this in your note? I think I gave this in here more than once. And you're waiting for me to come before you read it. My profession is teaching. I will teach. Your profession is studying. You are supposed to study. I can't teach and study for you. Okay. So we have a tangent touching the circle at a point. Where it touches the circle at a point, that point is called what? What name is given to that point? Point of what? Yes. Point of tangents. So if this place here is our P, we can say the point P where the tangent touches the circle is a point of what? Tangents. So if you have a chord drawn to that point, if this chord is PQ, the chord PQ will make two adjacent angles with the tangent. This is our tangent. This is one of the angles. We can call this one theta and call the other one phi. Clearly, you can see that theta is made with the tangent in the minor segment of the circle with the chord PQ. What about phi? Phi is made where? Oh, open your mouth, yes. Phi is made in the major segment. Okay. The same chord PQ can also subtend what? Angles at the circumference, both in the major segment and in what? The minor segment. If it subtends this angle alpha in the major segment, because the chord PQ makes the angle theta with the tangent in the minor segment, if it subtends alpha in the major segment and the circumference, they are supposed to be what? Equal. If it subtends an angle beta in the major segment this way, sorry, in the minor segment, beta is subtended in the minor segment of what? PQ. The same PQ is making the angle phi in the major segment with the tangent. So beta will be equal to what? Phi. So with this we can say that alpha is equal to what? Theta, and beta is equal to what? Phi. Right? Now what I want us to add to this tangency theorem is the theorem of the normal. So write down that somewhere. It says that the radius of a circle is normal to the tangent at the point of tangency. The radius of a circle is normal to the tangent at the point of tangency. What do we mean? If this is our circle, center O, tangent to the circle point of tangency is here. If you draw a straight line from the center to any point of the circumference, that represents what? That represents what? Yes? It represents what? Radius. Fine. Meaning that if we cut a straight line from the center O to the point of tangency, that will be a radius, isn't it? And that theorem says that when we draw the radius of the circle to the point of tangency, the radius is automatically what? Normal towards to the tangent at the point of tangency. What is the interpretation of the normals? What does it mean? It means it's what? You are not confident in what you are saying or what? Feel free. Yes, yes. If it's wrong, I'll correct it. Yes. Yes. The interpretation of the normalcy is that the radius is perpendicular to what? To the tangent at the point of what? Tangency. Meaning that the angle there is what? 90 degrees. So anytime you have a point of tangency and you draw a radius to the point of tangency, automatically it is normal to what? To the tangent at the point of what? Tangency. So the angle between the radius and the tangent at the point of tangency is always what? Always what? 90 degrees. Okay. The application of this, or the extension of this theorem, is most of the time seen in double tangency from a given point. So I'm extending that. Now if I have another tangent, that is, if I have another tangent this way, and also generate another point of tangency here, if this is P, let me call that one what? Q. For this we can also draw radius to the center And obviously, if we take this at the point of tangency, the angle there will also be what? 90 degrees. What this means is that if we should join the point at which these two tangents are intersecting to the center, if we should join that point to the center, we end up generating what? Two identical what? Right-angled triangles. So we said these two right-angled triangles are what? They are what? They are congruent. So we end up generating two congruent what? Right-angled triangles. We generate two congruent what? Right-angled triangles. Fine. If the radius of the circle is given, and we know either the angle that the two tangents make at the center of the circle, or the angle between the two tangents at the point of intersection, then by application of the trig ratios of what? We can find the distance between the center and what? And the point. Or find the length of the tangent from that point to what? The point of what? Tangents. Right? If the radius of the circle is given, and we know the angle between the two tangents at the point of intersection, assuming the angle between the two tangents at the point of intersection is theta, meaning that if we pick the top right angle triangle, for instance, this is what? 90 degrees. Agreed? This is O, this is Q. If the point of intersection is T, for instance, this angle here will be what? Theta over 2. Agreed? Can we all see that? That will be theta over 2. Because this is a congruent triangle. The line joining the point T to the center will exactly bisect that angle, because the right angle triangles are what? Are congruent. And if exactly bisect the angle, then it means that one of them will be exactly half of what? Of theta. If that angle is known, and you know this radius r, the length of the tangent, which is what? TQ or QT, or the distance between the center and the point T, which becomes the hypotenuse of what? Of the triangle. Both can be found. Write an expression for QT using the angle theta over 2 and radius r. Let me see. Write an expression for that. Write an expression for that. Let me see. If you are done, let me see your hand up. Write an expression for that. Are you doing on the table? And where is your daughter? This is your daughter. Your notebook. So where is your daughter? The daughter is in the desk, and you are writing on the desk. Yes. You know what? You haven't started. Why? You are writing an expression for what? QT in terms of what? Theta over 2 and the radius. Where you pay attention? Then how can you be lost? You can't see the diagram. Oh, the camera is not here. They relocate. We are looking for what? QT. R is given. If R is given, the angle we are working with is what? The angle here, which is theta over 2. What's the relationship between theta over 2 and TQ? Is what? Who is, yes? What is it? It's adjacent, isn't it? Speak out. The relation is what? With relation to theta over 2, TQ is what? Is adjacent. And what do we know? R is what? Is the opposite. So adjacent and opposite. Which ratio are we going with? This is what? Opposite and adjacent. Right? So we can say that tan what? Theta over 2 is equal to what? Opposite over adjacent, which is what? TQ, isn't it? And we are going to write an expression for TQ. So what do we do? Multiply both sides by TQ. We have what? TQ tan what? Theta over 2 equals what? R. It therefore follows that TQ is equal to what? R over what? Tan theta over 2. This is an expression for what? For TQ. Agreed? How many people got it? I saw just about 2 people who got it. The hands that are shooting up are far more than the correct answers that I saw. So what was the problem? Why were you lost? Okay, now write an expression for OT. Let me see, write an expression for OT. Fast. In terms of what? R and theta over 2. Write an expression for OT. Fast. OT and the angle. OT is what? The hypotenuse, isn't it? OT is the hypotenuse. And what else do we know? We know the opposite to the angle, isn't it? So we are dealing with opposite hypotenuse. Opposite hypotenuse, which one do we pick? This is what? The sine ratio is the one that deals with what? Opposite what? Hypotenuse. So it follows that sine theta over 2 is equal to what? Opposite over hypotenuse. That will be what? R over OT, isn't it? So our OT sine theta over 2 is equal to what? R. Therefore, OT is equal to what? R over sine theta over 2. Agreed? Fine. If this is understood, if this is understood, then it also follows that if we know the radius and know one other side, it could be the length of the tangent. Are you with me? If we know the radius and we know the length of the tangent, or the distance between the center and the point of intersection of the tangent, then we can also find the angle that the two tangents made with each other, isn't it? What will that give us? It's either this way, giving us what? From here, what will this give us? Theta over 2 will be equal to what? Sine inverse of what? Of R over what? TQ. And if it is in this form, what do we have? Theta over 2 will be equal to what? Sine inverse of what? R over OT. Depending on which one is given with the radius. Is that clear? Yes. So can we do something with this? Yes. Fine. Then try this one out for me. These two. Okay. Find the length of the tangents PR. That is the circle. O is the center. The radius is given as what? 9 centimeters. The two tangents are intersected or intersecting at what? At R. The angle that they make between the two of them is 36 degrees. So find the length of the tangents PR. Today is a Friday. Where theta is equal to what? 36 over. No, theta is equal to 36 degrees. Because theta over 2 will be 36 over 2. So theta is not 36 over 2. Theta is 36. Or you are all using theta is equal to 36 over 2. Okay.